Black holes are super mysterious objects. They exist far away in space. Imagine a place with ultimate power, a place that pulls everything in. Scientists find them truly fascinating. They work hard to uncover secrets. These objects challenge our understanding. Let's explore these cosmic wonders now. For many years, people have wondered, what are these strange, dark things? They are not empty holes at all. Instead, they are full of stuff. This stuff is squeezed incredibly tight. This makes their gravity super strong. So strong, nothing can ever leave, not even the fastest light. The idea of black holes is not new. It started a long time ago. Scientists used math to predict them. Later, astronomers found real evidence. They saw stars moving very oddly. Something invisible was tugging them. That invisible something was a black hole. Now we use amazing telescopes. Our journey today will be exciting. We will learn what black holes are. We will discover how they are born. We will explore their important parts, and we will see why they matter. Get ready for a super space adventure. It is going to be very interesting. Let's dive into the world of black holes. So what is a black hole truly? It is not an empty space or hole. It is a huge amount of matter. This matter is crushed down small. Imagine taking a giant star, then squashing it into a tiny ball. This creates an amazing gravitational pull. This pull is the black hole's main feature. This gravity is the most powerful force. It is found around the black hole. It pulls on any nearby objects. If something gets too close, it's caught. It gets pulled into the black hole. It cannot escape this mighty grip. This includes planets, stars, and gas. Even light gets trapped inside it. Because light cannot escape its pull, black holes are completely invisible to us. We cannot see them in the dark sky. Usually, light bounces off an object. Then this light comes to our eyes. That is how we see everything. But light goes into a black hole. It never ever comes back out. Scientists are very clever detectives. They find black holes in smart ways. They look at the things around them. Stars might orbit an empty spot, or gas clouds might get super hot. This gas heats up as it spirals in. It glows brightly before it vanishes. These are clues a black hole is near. How does a black hole come to be? Many black holes start as giant stars. These stars are much bigger than our sun. We often call them massive stars. They live for many millions of years. During their lives, they shine brightly. They quickly burn through all their fuel. This fuel is what creates their energy. This energy pushes outwards from the star. At the same time, gravity pulls inwards. For most of a star's amazing life, these two forces are perfectly balanced. The star is stable and shines steadily. But the massive star eventually runs out. It has no more fuel left to burn. So the outward push sadly stops. Now gravity completely takes over. The star's core collapses very fast. This happens in just a few seconds. This core collapse is incredibly powerful. The outer layers of the star explode. This huge explosion is a supernova. A supernova shines brighter than galaxies. It lights up space for a short time. But what happens to the star's core? If the star was big enough, it shrinks. The core keeps collapsing under gravity. It gets squeezed smaller and smaller. It becomes incredibly dense and tiny. It then becomes a stellar black hole. Not all massive stars do this, though. Only the very biggest ones can. Stellar black holes come from big stars. These stars collapse at their life's end. But there are other types of black holes, and they might form in different ways. Supermassive black holes are one type. These are the true giants we know. They are millions of times our sun. How they formed is a big puzzle. Scientists think these giants grew slowly. They might have started as smaller ones. Then they merged with other black holes, or they ate huge amounts of gas. They also swallowed many nearby stars. This likely happened early in the universe. It was like a massive cosmic feast. Understanding this growth is very important. There is another cool idea for black holes. These are called primordial black holes. These are still just theoretical objects. Scientists think they formed after the Big Bang. The universe was very hot then. It was also incredibly dense everywhere. Small, dense areas might have collapsed. They could have directly formed black holes. So, black holes are not all created equal. They come in many different cool sizes. They can form in different situations too. Some are born from huge dying stars. Some from mysterious early universe events. Some grow by eating over long times. The universe is truly full of surprises. Black holes are amazing cosmic creations. Section 5. A family of giants, different types of black holes. Let's meet the diverse black hole family. First, we have stellar mass black holes. These are the most common type. They form from collapsed massive stars. Their mass is usually quite predictable. maybe 5 to 20 times Sun's mass. Sometimes they can be even heavier. Our Milky Way galaxy has millions. Then, there are supermassive black holes. These are the real heavyweights here. They are incredibly huge and massive. They can be millions of sun masses, or even billions of times Sun's mass. Scientists think most big galaxies have one. They sit right at the galaxy's center. Our own galaxy has one called Sagittarius A*. There might also be another kind. These are intermediate mass black holes. They are the middle children here. They would be bigger than stellar ones, but much smaller than supermassive ones. Their mass might be hundreds of suns, or maybe thousands of sun masses. Scientists are actively searching for them. Finally, some scientists talk about something else. They discuss micro black holes too. These would be extremely, extremely tiny, perhaps even smaller than a single atom. These are purely theoretical for now. Some theories say they formed early, maybe in the very early universe, but we have not seen any yet. Section 6. The Edge of Forever. Understanding the event horizon. Every black hole has a boundary called the event horizon. It is the point of no return. Gravity becomes too strong here. Even light cannot escape. This is why black holes are black. Section 7. Into the unknown. The mystery of the singularity. What amazing thing lies past this boundary? Past the mysterious event horizon, what's there? At the very heart of a black hole is something called the singularity. This is where all the matter goes. All the matter that made the black hole. It is all crushed into one point, an infinitely small, tiny point. A singularity is a very strange place. It is a place of infinite density. Density means how much stuff is packed tightly into a certain space. Infinite density means endless stuff, all of it in absolutely zero space. This idea is very hard to imagine. Our current physics breaks down here. Scientists use two big main theories. These theories describe our universe. One is general relativity for gravity. The other is quantum mechanics for small. These two theories work very well, but they do not agree on singularities. We need a new, better theory. A theory of everything is needed. So, the singularity is a huge mystery. Is it truly a point of infinite density? Or is it something else entirely new? Something our theories can't yet describe? Some scientists think new physics exists. It might prevent an actual infinite point. Maybe it is just super dense. Unlocking this is a very big goal. Section 8. Cosmic Architects. Why black holes matter to the universe. Black holes might sound quite scary. They might seem very destructive too, but they are also very important. They are vital in our universe. They are not just cosmic vacuum cleaners. They play a very big active role. They help galaxies form and change, especially the supermassive black holes. Supermassive black holes can change things. They affect their entire host galaxy. As gas and bright stars fall in, they heat up to very high heat. This creates powerful jets of material and also strong winds of hot gas. These jets can shoot far into space. These outflows can clear out much gas. Black holes are also amazing labs. They are natural cosmic laboratories. They let us test our gravity theories. Albert Einstein's big theory is one. His general relativity predicts black holes. Studying them helps us see if he's right, especially where gravity is super strong. So far, his theory has passed tests. By studying all these black holes, we learn about many extreme things. Extreme gravity and extreme density. Also, extreme energies are studied. Understanding these helps us understand. It helps us learn about the universe, its past, its present, and its future. They are key pieces in the puzzle. Section 9. Conclusion. The adventure of discovery continues. Wow, black holes are truly amazing. They are very incredible cosmic objects. We've learned they are super strong. Regions of extremely powerful gravity. Nothing, not even the fastest light, can ever escape their mighty pull. They form from massive dying stars, or in other more mysterious ways. Black holes are much more than this. They are more than cosmic curiosities. They are powerful dynamic forces. They actively shape entire galaxies. They help us test laws of physics. They challenge our basic ideas about space and about time. From stellar black holes to giants, scientists are still learning so much. There is much more to know. Every year, new discoveries are made. We have amazing tools for this. Telescopes on Earth and in orbit, like Hubble and James Webb Space Telescope, and the Event Horizon Telescope too. It even took a picture of one. The great adventure of exploring black holes is not over. It is actually far from being over. There are still so many questions. What really happens at the singularity? How did giants get big so fast? Are primordial black holes really real? Future missions will search for answers.